The purpose of this video is to provide another explanation on the computation of the naive method, the moving average method, and the exponentially smooth model. I'm going to begin with the naive model. The naive model is essentially the actual from the previous period copied down to the following period. So let me show you here using Excel. So you can see there for period number 2, which is in 2007, the value for the naive model is the actual for period 1, which is in 2006. So I've copied the 500 to here, and you'll notice that the 500 now is here in 2007. Now using Excel, I can just copy this formula down, which makes it kind of easy. So I click on the box, I grab it from here, and I pull it all the way down. And now I have the naive model, and I've copied it all the way down, which makes it the math a lot easier. So that's how you compute the naive forecast. Now we'll do the moving average. For the moving average, you need 3 previous months of data. So if we're going to start here, the first time we would be able to actually do this would be in 2009. So in 2009, the forecast would actually be the sum of 2006, 2007, 2008 divided by 3. So to do that in Excel, we're going to calculate it as 500 plus 565 plus 644.94. We have to close parentheses, and then we're going to divide by 3. This value, 570.08, that's the forecasted amount for period 2009 using the moving average model. Now we're going to copy that down so that we don't have to recalculate it each and every time, and we're just going to pull it down like this. Makes it a lot easier. And one thing I didn't point out, I'm just going to do quickly, is I'm going to add this round term in here. We're going to round this equation to 3 decimals, and so that's what I have indicated up here in the top. I hope you can see that. Because I want to make sure that my values turn out like I told you to do them on the calculator, so I have to put in this round function. Once I have that in, I can just copy that down, and it's probably not going to change anything, but it could possibly when we get over to the next column over here where we're going to do exponential smoothing. Okay, now when we're going to do exponential smoothing, we are going to set up our formula here in this first equation. So you'll see I've got some numbers in here because I wanted to get it done a little bit ahead of time so you didn't have to watch me do everything. But we're going to click up here on this formula because I think that's a very useful tool. You just click on it and then it highlights the cells that you're working with. So in our case, we want to do the f of t minus 1, so that's f of the time period before, that's the f of 1, which is, this is 495 here. So let's just delete this 495 and we'll click on that box there. So that will be replaced with f of 5. Then we're going to add to that the quantity of the alpha times the difference between the actual and the forecasted amount. So we've got the actual amount here located in C5, that's this 500 right here. And then we have minus 495, and we're going to hit this again to get rid of that. So now, when we get everything in, we'll be able to roll the equation down. So we've got our formula in there, and we also have the rounding in. So we're going to hit equals, and we get this 495.50. Now, if we've done this correctly, we should be able to pull it down and it should calculate the next month for us. But let's look and make sure, because we want to be sure that we're using the forecast from the previous period, which we are, and the actual from the previous period minus the forecast from the previous period, which it looks like we are, and we're rounding it to 3 decimals. Now, if I'm right with what I have told you in class, and that this model doesn't consider a lot of the difference between A and F, then when we pull this down, what we're going to find is that the forecast doesn't keep up with the actual. So let's just pull it down and take a look and see what happens. Now look at there. Notice that the forecast lags the demand, which is right here, more and more and more each month. Look at that. And that's because we have such a small alpha here. Had we done this with a larger alpha, you would see that this would not lag demand quite so much. As a matter of fact, I can just quickly put in a column and show you that, and you'll just be able to see the difference. Alright, so I just quickly set this up. I've got my 495 in here in period 1 or 2006, and here I have changed our alpha to 0.9. Now everything else is the same, the rounding, everything else, and we'll pull it down. And look here, look at the difference between this last period, 2015, and this model, right? So exactly the same forecasting model, but the difference is the alpha. So here we've got a large alpha, and here we have a small alpha. So we can just make a little note to ourselves here that the large alpha will consider a larger amount of the difference between the actual and the forecast. Thus, a larger alpha is more responsive to changing demand, which is what I told you on the handout and I told you in class, but sometimes I think it's just easier to see it. Okay, now the last part of this video is just going to be to show you how to calculate the absolute error. So remember from class we talked about the math has two parts. The first part is calculating the period differences, and then the last part is summing the values down. So we're going to start here with ABS, because that's the absolute value command in Excel, and we want the absolute value of the difference between the actual and the forecast. So the actual is here, this, minus our forecasted amount, which is here. And then we can pull that down, right? It's just the absolute value of the difference between the forecast and the actual amount. Now for the moving average, we're going to do the same thing. ABS, open parentheses. Again, we're going to go over here, click on the actual, and subtract from that the moving average amount. And actually, we'll copy this down, but then I just remembered something. Let me go back over here. I believe, yes, this is in the column for the naive error, but really ought to be over here for the naive. I had used before the exponential smoothing forecast there, so I'm just going to copy that down. So this is the naive error, and notice it's got the actual minus the naive. Now over here we just did the moving average. We've got the actual minus the moving average, and then finally we can do the exponential smoothing, which we had done before. ABS, it'll be this 565 minus 495, and we'll copy that down. Now if we wanted to include our other little column that we made, we could do the MAD for our higher alpha calculated value here, and we'll just do that quickly. So I have the first one in there, the absolute value of the difference between the actual, let's see, it's right here, and this new forecasted amount. And then we'll copy that down. Now, to calculate our actual MAD, these are all our individual calculations that are required each month in order to calculate our overall MAD. And we have to take the average of all of these values. So in Excel, that's pretty easy. We can just go right up here and hit this down arrow on the auto sum and say average, and it'll probably capture the right column and everything. So we've got 8839 for the naive, and then we can go here for the MAD for the moving average. Same thing, we'll just do average, and it will capture that and have it at 183. And then we can do, for the exponential smoothing, again, we're going here to the sum, we're taking our average, and we have 337. And then finally, just for fun, because we're doing it, why don't we go ahead and calculate the MAD for this last column, even though I didn't really ask you guys to do this, but just because we can. We'll hit average. And you can see that it's pretty low, although it isn't actually lower than the naive model. And remember, the naive model is the one that changes every period based on the previous month's demand. So I just wanted to give you a quick little summary. I wanted to keep it to 5 minutes, so it turned out to be 8, but I wanted to give you a quick summary of how to do each one of these methods, and I wanted to show you how to do it in Excel just because I find that useful. And now you've got the numbers that you need to know. You can check your own work to see if you've got all this done correctly. I will go through these answers here. What should be the student loan debt for 2016? So for that, we could just easily pull down each of our values, easy enough. Right, so depending the model, we would have one of these three would be our answer there for the answer to this question here. 1200 or 1207 or 799. And which is the best forecasting method? Well, that's what we were just talking about. It's going to be the one with the lowest MAD. So in the case of the three models I asked you to do, it's going to be the naive model. And then, why does the moving average lag the demand? Well, the moving average will always lag demand because moving average is considering the previous 2 months, which are often lagging. So that always seems to lag demand. Okay, I hope this was helpful. We'll see you soon. Bye.